Hello, my dear students, and the rest of the learners. Welcome to part 30 of a 95-part series of tutorials in object-oriented programming series in C++. In this presentation, we are going to focus on implementation of objects and classes with our attention being on what we call the constant or const specifier. My name is MemJM, or you can simply call me Swap. A const or constant specifier is a qualifier that explicitly declares a data object as something that cannot be changed. Its value is set at initialization. You cannot use const data objects in expressions that require a modifiable value. In C++, therefore, all the constant declarations or const declarations must have initializers except those referencing externally defined constants. A constant object or a const object can appear in a constant expression if it is an integer and it is initialized to a constant. Some objects need not be modifiable and some do not. You can use the keyword const to specify that an object is not modifiable and that any attempt to modify the object should result in a compilation error. The library programmer desires that one of the member functions of his or her class should not be able to change the value of the member data. This function should be able to merely read the values contained in the data members, but not change them. So, if a programmer declares a function as a constant function, if the function attempts to change the value of a data member through the function, the compiler should return an error. The member functions, on the other hand, are specified as constants by suffixing the prototype and the function definition header with the const keyword. For constant members, the members occupied by the invoking object is a read-only memory. I repeat, for constant members, the memory occupied by the invoking object is a read-only memory. The memory, therefore, manages this by making the this pointer to become a constant pointer to a constant instead of only a constant pointer. Only constant member functions can be called with respect to constant objects. The non-constant member functions, therefore, cannot be called with respect to constant objects. However, constants or a constant as well as a non-constant function can be called with respect to non-constant members. The following is therefore a sample program implementing constant members. It prompts the user for radius of a circle, computes its area, and displays both the radius of the circle and the area on the screen. I have given this program the name class Const Specifier. We have the preprocess directive there. We have the definition of the namespace or declaration of the namespace, that is using namespace standard. And then our class is called circle. This class, as I, is a private member, which is expected to hold value that it has a fractional part that is type double. We also have area and radius as members or private members of type double. In addition, in this class, we have a method. This method has been prototyped. It is not receiving any parameter and it's not expected to return any value. And its name is getRadius. We also have another member who is a method by the title or by the name or by the tag compute area. This method is not expected to receive any parameter, neither is it expected to return any parameter, and it is of type const. Similarly, we have another member called pi_value. This is a method. This is a method. And this method is expected to handle value, which is constant. That means that memory that is going to be accessed by this function is expected to be, or the content expected to be, a constant. We also have another member or another method called setPy. This method is expected to receive a parameter of type double, but not return any value to the invoking function. And that's the end of that class. So this class has 3 data members who are private, and it has 4 public members, or members who can be accessed from outside the class as long as they are within the scope of the class. And those that are handling constants, or those that are constants, include compute area. And also we have seen that pi value is also expected to manipulate value that is constant. We now define the function called pi value. Now this pi value is expected to return a value of type double, and its scope is the class called circle. We can see it is receiving or accessing a memory that is holding a constant value, and the content of that memory is being returned as pi to the caller. Next, we have setPy function. The setPy function has the scope of the circle class. It is expected to receive a parameter of type double by the name I, but it's not expected to return any value. We are initializing the value or the memory location called I with 3.142. And then we assign that value that is stored in memory location called I, or in parameter, or in the memory called I, to pi. And then we are invoking a function called pi value. We are calling pi value function. And what does pi value function do? Pi value function, as we have seen, is expected to return the value, of pi. We then move on to the main function, where we are declaring an object to be used to manipulate the members of the class called circle, and the name of this instance is circle object. We are then invoking the function called setPy by passing to it a value, or initializing setPy to 0 through the object for the class circle. We are also invoking the function called getRadius through the object called circle object. From there, we invoke the compute area function through the object called the circle object. So the compute area function is a member of the class called circle, whose content is being manipulated by the object or instance called circle object. So when we invoke this function called setPy, the compiler will go to the class called circle that's being manipulated by the object or the instance we have talked about, and then it's going to invoke getRadius function. Where is getRadius? GetRadius function has been defined outside of the main. Here it is. So the compiler will come and look for getRadius definition. What is it doing? It is prompting the user to enter the radius of a circle. The value entered by the user is read into memory location or into the member called radius. So that's the work of getRadius function. Its work is purely to read the value entered by the user and keep it in the location or in the member called radius. So the compiler will go to the class, it will go to the class and assign the value entered to radius. From there, the compiler will go back to the main function and invoke the next statement here. The next function is, we have seen, I repeat, that the first one is setting pi, and 0 is being set to the function, or is being sent to the function called setPy. So the function called setPy, is here. So we can see it is going to receive a 0. And this is the prototype. So the compiler will go and look for the definition of setPy. Here it is. So the value 0 will be received as I. So I will be initialized to 0. But then from there, it is then that memory location called I is then being assigned value 3.142. And that value is then assigned to memory location called pi. From there, the pi value function is invoked. The pi value function is invoked, and we can see it's going to return pi. Then we go to this other function here. We have seen its work. Its work is to get the value of radius. Once that is done, the next will be to compute the area. So once this function is invoked, the compiler will go to class called circle, look for compute area function. Here it's its prototype. It will then go and look for the definition of that function. So where is compute area? Here it is. So this function is going then to multiply the content, or get hold of the content in the memory location or in the member called the pi, multiply with what is in memory called radius, multiplying by itself again. And the results will be stored in the area member. Then it will display the message on the screen. The area of the circle's radius is, it will pick the memory or the value in the memory location called radius. Whatever is there will be displayed on the screen, followed by S. Then the compiler will pick whatever is in memory location, or the processor will pick what is in memory location called area and write it out, and then drop one line below. Once this place is encountered, then the control will be taken back to the main function. What is next? The next is to return the control back to the operating system, and the program will end. So my dear students and the rest of the learners, that's how that function or that program will work. The following is therefore a demonstration on how this program is compiled and executed in C++ and the kind of output that it will generate. In other words, my dear students and the rest of the learners, just as you have been doing, just copy this program in your exercise book or in your word processor. And once you have copied it, then you can start C++ program. So I'm going to start my C++ program. Once you start your C++ program, you can then proceed and initiate our new project. Remember, I'm using Visual Studio C++ 2010. What is important for you is to be able to launch your C++ program, then launch your editor in your IDE, and then type the code that I've already explained. So what is the name of my program? This program that I want to code include the project. I'll call it class Const Specifier. Class Const Specifier. So let me type class Const Specifier. And then I'm going to proceed. And create the file and the project that I've already created. So I want to code my program, and the name of my program or my file will be class const specifier. My dear students and the rest of the learners, once you are in your editor or on your editor, you can then type your code on your editor, or just copy your code and paste it here. In my case, I have already typed my program in a word processor, and therefore what I'm going to do is to just copy my program and paste it on my IDE as follows. So here is my program. So I'm just going to copy my program as follows. And once I copy my program, I will go back to my C++ editor, and then I'll paste my program here. So this is my program. Remember, it's good for you to ensure that you ident it well. So this is my program. You can either copy and paste as I have done, or you can just type your statements directly on your editor. However, just as I've said before, it's always good to write your program in an exercise book or in a word processor program, and then go through your program, dry run it. Once you are convinced that it's okay, you then transfer it to your C++ editor. Then save your program. And after you save it, you compile. So in C++ 2010, we click on build. So let's compile our program. You can see that my program has succeeded. So the source code has been converted to object code. There's no error. And now that there's no error, we can then run our program or execute our program by clicking on debug and then start without debugging. You can, if you're using another version of C++, you can just follow the steps for compiling and also for executing your program. So you can see my program is prompting me to enter radius of a circle. Where is that? Yeah, it is. It is the function called get radius. So we type, for example, 23. You can see it is able to compute. The other function has been executed for computing the area. So which function is that? And where is it? Can see our function for compute area is this one here. So it has been invoked and computation has been done and the results have been displayed on the screen. And that's the end of our program. So you press any key to continue. Always remember to save your program. So my dear students and the rest of the learners, you can see how we are able to manipulate the const specifiers or members that have been declared using the const or reserved word const. It is my hope that you have been able to understand how the const specifier works. And for that reason, my dear students and the rest of the learners, we have come to the end of part 30 of this series. You can continue to part 31 of 95 of this series, in which we are going to be learning on what we call the pointers to members, still under the continuation of the topic implementation of objects and the classes. Congratulations for learning part 30 of 95 on a const specifier and the implementation of objects and classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos, by clicking or tapping on MLSwap ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. You can also join this channel, that is MLSwap ICT YouTube channel, as a super member or as a fan by clicking on join button to support the production of more of videos or other areas of interest. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 1 of this series, and God bless.